about increasing and decreasing functions. So just to recall, when reading a graph, what we do is we read it from left to right. Okay, so just as an example, we would start at the very most left, and then wherever it goes, read it to the right. So we would always read it this way, where these arrows are pointing. Okay, so just like a book in English class. When we read a graph, we want to determine whether the graph is increasing or decreasing. What we do is we focus on like the y-axis. So 1, 2, 3, 4, or -1, -2, -3, -4. Okay, what we do is we focus on, like, we talk about the x's, but in terms of y. So we talk about, are the y's increasing or are the y's decreasing? So are the y's getting bigger, which is moving up, or are the y's getting smaller? Okay, bigger, which is up, or smaller. Okay, in other words, increasing is when the y's are going up, and decreasing is when the y's are getting smaller. Okay, we don't look at the negative or positive number. What we do is we just compare the numbers. Okay, we determine the intervals where functions increase and decrease in order to understand the behavior of a function. That's the whole purpose of this. So here it is in mathematical terms, intervals of increase and decrease. We say that a function f is decreasing on an interval if for any value, the second value, right? So if we look at x1, which is to the left, and then it moves towards x2 on the interval, f at x1 is greater than f at x2, okay? So this y value of the first value is greater than y of the second value, which just means it's going down. Okay, similarly, we say the exact same thing, but the reverse for any value increasing. So let's talk about decreasing then increasing. Okay, so if one's increasing on an interval, when we compare x1 and x2, so for example, x1 would be here and x2 would be here. x2 is always the later, right? What happens is the y value of x1 is smaller than the y value of x2, right? So it'd be 0 compared to 3, for example. Okay, so for example 1, let's just examine the equation f at x equals x squared. So we've seen this since grade 10, okay? But now we're going to take a look at this in a calculus approach. So let's talk about intervals of increase and decrease, okay? So this graph is increasing and decreasing. So this graph is increasing from, let's round that right to 1. For simplicity, from 1 to infinity, right? Because these y values continuously go up. So it's increasing on 1 to infinity. Okay, it doesn't include 1 because it's actually turning around at 1 where like the slope is 0, right? And it's decreasing because, so remember, we start on the very left and we read like a book to the right. Okay, so it's decreasing on negative infinity all the way to 1. Okay, and it's neither increasing or decreasing at x equals 1. Now we can also talk about the tangents, okay? So if we draw a couple tangents to this curve, what's going to happen is on the left-hand side, the tangents are all going to be negative. So f prime at x is less than 0, so it's negative. We can say on negative infinity to 1, right? F prime at x equals 0 at x equals 1. And f prime at x is greater than 0, so they're positive tangents, positive slopes, positive rates of change on 1 to infinity. And just to match this up with the actual derivative, if we solve for the derivative f prime at x equals 2x, we can see 1 is 2x greater than 0. Well, divide by 2 when x is, less than 0, when x is less than 0. We can say when does 2x equal 0? Well, when x equals 0. Okay, we see that. And then when does 2x, when is that greater than 0? Divide by 2. X is greater than 0. Okay, and that's how we get our, this is algebraically, and then this one here is just analyzing the graph. So let's just read this together. For functions that are both continuous and differentiable, we can determine intervals of increasing and decreasing y values using the derivative of the function. Okay, so when slopes of tangents are greater than 0, so what they are positive values. Let's go back on here. So they're positive values. It corresponds to the increasing portion of the graph. Okay, and when slopes of the tangents are negative, so when f prime at x is less than 0, it corresponds with the decreasing portion of the graph. Okay, what we're going to do is next we're going to use software to graph functions, then we're going to analyze them. I'll continue in the next video.